Today's lesson objectives, students will classify polygons. So first of all, what is a polygon? A polygon is a figure that is formed by 3 or more line segments. So it's important that you understand the sides have to be lines. That means that there are no curves when you're drawing a polygon. So I can't have several straight sides and then draw a curve. That is not a polygon. So just so we're clear on that, that is not a polygon. Okay. Each side intersects exactly 2 sides at each endpoint. So for instance, if I draw this here, each of those sides is intersecting. Each endpoint has only 2 sides that it touches. So for instance, if I were to draw a figure like this, and I went down and I went through and I crossed the sides, that is not a polygon because this side going through the middle is actually intersecting 4 sides. So that's not a polygon. Because when you look here, it's intersecting 4 times. So, and a vertex is just the end point of the side. So we already drew some over here. Vertices is the plural, vertex is 1. So a polygon has to have 3 or more line segments for the sides. The vertex is an endpoint, and each side can only intersect 2 sides. So we can't have a side intersecting 4 sides. Okay. So to name a polygon, we need to have a way to refer to them so we know what we're talking about. What you do is you list the vertices in order. Now, it doesn't matter what direction you go or where you start, as long as you go in order going around the polygon. So the obvious name for this particular polygon would be starting at A and just going alphabetically around the figure A, B, C, D, E. That's one possible name, but I could decide to go the other way and start at E. I could call it E, D, C, B, A. Or I could just start someplace else, like I feel like starting at C, so I'm going to call it C, D, E, A, B. Any one of those is a possible name. Obviously, we can come up with 10 different names for this polygon, but any one of those will do. It makes it clear which polygon we're referring to. A convex polygon is a polygon where no line that contains the side contains a point inside the polygon. So in blue we have the polygon here. And if I make lines out of each of those sides, none of the lines cross into the interior of the polygon. However, if it's concave, then that means that either one or more of the lines will cross into the interior. So if this is my polygon in blue here, you can see that 2 of the sides, when I extend their lines, they end up crossing inside, and so therefore it is concave. An easy way to think of it and to remember it is that essentially one side is caved in. If it's got a side that's caved in, then it's concave. So if we look at these figures here, and I want to describe what they are, the first one I've got, it's not caved in, so it is convex. It's a convex polygon. If I look at this second figure, the problem is this endpoint is touching 3 sides, and so therefore it is not a polygon. In fact, it's 2 polygons put together. The third one that I'm looking at, it has a curved side. So because of this curved side, it's not a polygon because it has to have straight sides. So that's not a polygon. And then if I look at my fourth figure here, this one is a concave polygon. Because it's caved in 4 places. So the name of a polygon is determined by the number of sides that it has. So these are names that you have probably heard before at some point in your math career. If it has 3 sides, it's called a triangle. If it has 4 sides, the general name that we use is quadrilateral. If it has 5 sides, it is a pentagon, just like the Pentagon in Washington, D.C. 6 sides is a hexagon. And 7 sides, this one's one that people don't usually know, is a heptagon. If that has 8 sides, it's an octagon. Nine sides is a nonagon. Ten sides is a decagon. We've got the Latin root deca, like a decade is 10 years. So a decagon has 10 sides. And then 12 sides is a dodecagon. Do for 2, deca for 10. 10 plus 2 is 12. And then for everything else, it just depends on the number of sides. So in general, if it has n sides, I'm going to call it an n-gon. So you may have noticed we skipped 11. There are a couple of different names for figures with 11 sides, but we're not going to use that in here. We're just going to call it an 11-gon. So an 11-gon has 11 sides. A 25-gon has 25 sides, etc. You get the idea. We just pick the number and then put a hyphen and gon after it, unless it's one of these that are in the table. So in order to be considered a regular polygon, a polygon must be convex, it must be equilateral, which means all the sides are congruent, and it must be equiangular, which means all the angles are congruent. So if this is a regular pentagon, then I know that all these sides are congruent to each other, and all these angles are congruent to each other, and I would mark it that way. So suppose I give you a figure like this, and I tell you that this side on the left here, the expression 3x plus 6 represents the length of that side, and on another side I've got 4x minus 2. And I want to find the perimeter of the pentagon. Okay, the perimeter of a figure is the distance going all the way around. Peri meaning around, meter meaning measure. So the perimeter is going to be the sides, all the sides added together. So because all the sides are congruent, I know that their lengths are equal, and so 3x plus 6 would have to equal 4x minus 2. So to solve that, I just subtract the 3x from both sides and add the 2 to both sides. And when I do that, I get that x is equal to 8. And now that I know what x is, I can plug it back in. So the side is just going to be 3 times 8 plus 6, so that's 24 plus 6, or 30. And so the perimeter is just going to be the number of sides times the length of the side. So the perimeter is just going to be 5 sides times 30 units for each side. The perimeter would equal 150 units.